All right, optimization. So we're looking for the maximum, which is as large as possible, or the minimum, which is the smallest possible. So we know that maximums occur at the top of parabolas, like where the slope of the tangent line is 0, or the minimum occurs at the bottom of a parabola where the derivative is 0. So we won't need to check our answers as far as like making sure that it's the max or min. It'll always turn out that way. But let's just go at it. Here we go. Two numbers whose sum is 20. So that means x plus y. Let me change pens. X plus y equals 20. Okay. X plus y equals 20. Okay, so that's a constraint. That's what we're restricted by. The one we want to find as large as possible, you want to think, that's the one I want to take the derivative of and set it equal to 0. So it's product, so I'll just say p prime equals 0. So the product of these two numbers, and be careful you keep the same letters, is x times y. So I want to take the derivative of this and set it equal to 0, but it's in two letters. So that means I need to take this, solve it for one of the letters, and substitute in. So I get x times 20 minus x. Always simplify so that you don't have to do product rule, all the things, right? So I get minus x squared. So now I'm going to take the derivative. Move this down. So if I take the derivative of this, I get p prime is 20 minus 2x. Whoops, 2x. Set it equal to 0. So 2x is 20, x is 10. And I find y by playing it back into here. So I get y is 10 and x is 10. Oops, 10. Okay, so that was finding those two numbers that were the maximum product. Let's look at this one. So I'm the dimensions of a rectangle whose area is 16. We cannot assume it's a square. So I've got an x and a y, right? So whatever that looks like. So we know area is x times y is 16. So that's our constraint. The constraint is always the one we use to sub into the one we're trying to maximize or minimize. Smallest perimeter. Okay, so in my head, I'm thinking I'm going to be taking the derivative of perimeter and setting it equal to 0, and that will give me the smallest. So let's set up the equation for the perimeter. You know that that's going to be 2x plus 2y. Then I'm going to solve this one for y, 16 over x, and substitute it in. So I get 2x plus 2, and I'm going to be 16 over x. All right, so now I'm ready to take the derivative, but it might be helpful to just rewrite this. So 2x plus, this would be 32x to the negative 1 power, correct? Now if we take the derivative, I get 2 minus 32x to the negative 2 power. I've said this lots and lots of times. Rewrite this as the negative, put the negative exponent in the denominator. So 2 minus 32 over x squared equals 0. 2 equals 32 over x squared. Let's see, multiplying by x squared, dividing by 2. I get x is equal to plus or minus 4. Okay, I know we can't have a rectangle of negative 4, so x has got to be 4. And if x is 4, put it in here, y is 4. Oh, so it is a square. But I couldn't assume that in the beginning. All right, so you're going to get problems like this one also. So we've got a rectangular plot of land that's bounded on one side by a river. So we don't need a fence there, but the other sides need a fence. So here's the river. And so I've got a fence, fence, fence. And so I'm going to put these two things as x, and that's a y. So we have 800 meters of fence. So 800 has to cover all three of those, so the two x's plus the y. And we want the largest area. Again, you want to be thinking that's the one you want to take the derivative of and set it equal to 0. So area is x times y. So I'm going to solve this one for y. So I get y is equal to 800 minus 2x. And then I'm going to sub that in. So I get a is equal to x times 800 minus 2x. Again, I want to simplify this before I take the derivative. So 800x minus 2x squared. Now if I take the derivative, I get 800 minus 4x, set that equal to 0. So put the 800 on the other side. So I get x is 200. And then how do I find out what the y is equal to? I take x is 200 and I put it in right there. So y is equal to 800 minus 2 times 200. So y is 400. So those are the dimensions.